Okay, lesson 8.3. We are starting into hyperbolas today. As I said, it will easily take today and tomorrow to get through these notes. They're very similar to ellipses. Ellipse notes I ended up having to take a third day, so there's always that possibility here. Not my plan, but there's that possibility. I know in class, Levi was making the comment that a lot of this stuff looks the same, and it is a lot the same. I shouldn't say same, similar. They're very similar pieces, but not exactly the same. So, by definition, a hyperbola is the set of all points in a plane whose distances from two fixed points have a constant difference. And I know you probably don't remember the definition of ellipse because it's been a while. It didn't probably make a lot of sense to you. But with the idea, the difference between hyperbola and ellipse in terms of definitions, ellipse definition read the same, except it was whose distances from two fixed points have a constant sum. Because it was a constant sum, those curves flipped in, they connected, they formed this ellipse. Here, because it says a constant difference, notice my hyperbola is these two curves facing outwards from each other. Similar to parabolas, but not the same as parabolas, but that same type shape facing outward. So no matter what direction we go, these hyperbolas will always face out from one another. We still have two fixed points called foci, okay, or two focuses, if that even sounds right. It doesn't to me. Now, difference here. Notice, here's my drawing, okay? You guys all have this in front of you, right? So your foci are now farther apart than your vertices. Notice my foci, a lot like in a parabola. The focus in a parabola was inside the curve, yes? The foci in a hyperbola are inside the hyperbolas. So they're inside the curves. The line through the foci is called the focal axis. So the focal axis is going to be the distance from one focus to the other focus. We had that same definition on the ellipse.
Wait, the focus of the vertex?
I'm still talking about focus right now.
Wait.
Focal axis is the distance between the vertices?
No, the foci.
Because it shows that it's between the vertices.
Yeah, why does it show that? I think
See?
either it's written down wrong or you said it.
Okay. Interesting. That's never been pointed out. I've never noticed that. Okay. So, virtual, let me catch you up. The discussion here in class is what I'm stating and what the picture is showing are not the same thing. Okay, so the line through the foci is called the focal axis. So the line going from one focus to the other focus is the focal axis. So the picture is slightly wrong in that this picture, and I don't know if I trust myself, let me try this in pencil first. Yeah, the focal axis goes from the distance from one focus to the other focus.
That's so weird.
So, and these notes were written up by Miss Byers, so I can't say that I've written them up, but I've used them for probably half a dozen years now, and I've never noticed it, and it's never been pointed out to me. So, but yes, the distance from focal axis, foci to foci, is your focal axis. That's what that was supposed to say there. Okay, the point halfway through the focal axis is called the center. So like an ellipse, you have a single center point, and that will be your HK value. Okay? The points where the hyperbola intersect its focal axis are the vertices. Okay, plural for vertex. So you have a vertex on each curve of the hyperbola, similar to where a vertex in a parabola would be. Okay, you have a vertex here and a vertex here. As I said, opposite an ellipse. In an ellipse, the vertices are farther apart, the foci are closer together. Now it's the opposite. My vertices are closer together, because they're right here. My foci are farther apart. Okay? And again, you're going to have these pictures and everything to keep you organized. Now, the chord line on the focal axis connecting the vertices is called the transverse axis. In an ellipse, bless you, in an ellipse, when you connect the vertices, it was the major axis. Here, it's called the transverse axis. So this is a lot like the major axis. It goes from vertex to vertex, which is why that focal axis is written wrong. Okay? And then the perpendicular line through the transverse axis is called the conjugate axis. So conjugate axis is similar to the minor axis because it's the one that's perpendicular through it. It would be kind of an invisible dotted line right here. It's not drawn in this picture. Okay? That's a little bit about all of our definitions up there. And we'll refer to those and keep using those. Like ellipses, we're going to have two charts for hyperbolas. On the front page, you'll notice hyperbolas with a center of 0, 0. So that means they're always going to be centered on the x and y axis. And then when we flip the page, I don't know if we'll get to it today or tomorrow, but we'll do hyperbolas with a center of HK. Okay? Now, as we look at this chart for hyperbolas with a center at 0, 0, okay, you will notice a lot of similarities between hyperbolas and ellipses. However, they are similarities. They are not exactly the same, which is a big part of the reason also that come test time I provide you with this information, because it's a lot to try and keep straight. Now, standard equation. What is the slight difference on the standard equation between ellipses and hyperbolas? Yeah. A hyperbola, the standard equation is x squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared equals 1. Now, you will notice a always comes first. You know, when we have one item minus the other, A is always the first item. There's good and bad here, okay? With the ellipse, the plus, we can just easily flip-flop them back and forth. With a hyperbola, you can't just flip-flop them back and forth because it's minus, and minus is not easily interchangeable. So with the hyperbolas here, it's pretty much set, which will come first, because you're always going to have your positive piece first. So if x squared over a squared is positive, it comes first. Or if y squared over a squared is positive, it comes first. The positive piece comes first. So to answer the question from earlier, here's the difference. A is not always bigger. Okay? The positive variable has your A value. And that positive variable will determine in the ellipse, it would be which is the major axis. In the hyperbola, it's which is the transverse axis, which is equivalent to major axis, so to speak. Okay? If your x value comes first, your focal axis is your x-axis. And so what you see here is the hyperbolas are on a horizontal axis, the x-axis. Your foci, this should sound familiar, plus or minus c, comma 0. Your vertices, plus or minus a, comma 0. Same thing you'd see if you went back to ellipses. Transverse axis, 2a. Does that sound familiar?
Yeah.
Except that was major axis. Conjugate axis, 2b, except that was minor axis. Okay, over here, it pretty much all was the same except focal axis. If the y value comes first, the y-axis is your focal axis, and what that means is that the main axis goes vertical, which now means my hyperbolas open up and down instead of left and right. You still have your foci of plus or minus c, your vertices of plus or minus a, transverse 2a, conjugate 2b. Okay? Yes?
So for this one, you say if the x is going to come first, it's going to be the left one, right? There's no other rule to that other than like when it was the last lesson. it was like,
If X is positive, it'll come first, you'll be in the left column.
okay,
If Y is positive, it'll come first, you'll be in the right column. Okay? Pythagorean relationship. What do you notice? It's similar, but yet
there's a plus.
there's a plus instead of a minus. Okay? I think of it this way. Our ellipse equation had a plus, but it was a minus in the Pythagorean relationship. Flip-flop that now. Our hyperbola equation has a minus in the middle. Our Pythagorean relationship has a plus. And again, you're going to have the notes in front of you, yes? Always remember to double check which is which. I think some of you have already been confused in using plus instead of minus already anyway, so
During,
maybe this will work. Huh?
will we have the equations even during test?
Yes.
Oh, okay.
Yep. Okay,
There's no quiz.
Well, wait.
one last thing.
Whenever we have a quiz,
There's no quiz.
no.
There's a test at the end of the chapter, which will be next week.
Okay.
I'm not doing a quiz in the middle of the chapter, is what he's saying. Because we're only doing 4 lessons in
Okay,
this
so-
chapter.
So I don't consider like quiz and test being something different.
That's what I was
Yeah,
wondering.
yeah, yeah.
That's why I was like, wait a minute. Which? Okay. Asymptotes. This is new. New in comparison to ellipses. Okay. Asymptotes are these imaginary, diagonal, dotted lines that you see up in your pictures. Okay. And those asymptotes, if you remember what an asymptote is, a graph can approach it and go close to it, but
Cross it.
does not cross it. And so when we draw these asymptotes in, they are going to help us determine the shape of the hyperbola. Now, you have a formula for asymptotes here of y equals plus or minus b over a times x, or flip your b and a to a over b here. I'll be honest, we're going to find those equations sometime, but I have another way to help you draw your asymptotes that I like a little bit better. And so we'll talk about that when we actually have to draw a hyperbola. Okay? So that's a little bit about the information. I want to start going through these problems, and you'll notice these problems are similar to what we did with ellipses, which is why I was so gung-ho that you have to understand how to do ellipses, because I'll be honest, if you were really still lost in the end of ellipses and not asking questions, hyperbolas aren't going to get any better for you. Okay? It just, now, they might get better in that the second time round, you might be understanding them a little bit better, but they are a lot alike. So, let's look at example 1 here. Find the vertices and foci of the hyperbola 4x squared minus 9y squared equals 36. Okay. Our ellipse notes start off with the same type problem. So you should have, the difference is now you have an idea of where to start at least. Hopefully. With any luck, I'm hoping. Did you have a question?
No, I was going to answer.
Okay. Where do we start?
Divided by 36.
Okay. To get this equation in standard form, we need it to equal 1. And so to get it to equal 1, we're going to divide by 36. If I divide that number on the right by 36, guess what? We're dividing everybody by 36. Okay? Clean up those fractions. 4 over 36 is going to reduce to
5 over, 1 over,
It's like squared over 9.
x squared over 9. Because 436 reduces to 1/9. And so it's 1 over 9. What about 9y squared over 36? Y squared over 4 equals 1. Now, I'm going to rewrite it one more time and put it in the form x squared over a squared minus y squared over b squared. Although I'm not sure you guys need that as much these days. Yes. Yes. Oh, that would be because after I took attendance, I forgot to move you guys over. I am so sorry. Thank you for saying something. Okay. I guess it only matters now that I've started writing a bunch. That's it. Okay. What are you guys talking about?
Well, I was talking about this.
Yeah, you wanted to subtract 35.
There are options here if you want to try and go crazy on me. Okay. What I was saying is I am going to, instead of writing as x squared over 9, what's the other way I can write this? X squared over 3 squared minus y squared over 2 squared equals 1. And the only, again, I'm not sure you really need that this time because I think you know how to find A and B better at this time. Okay, so before we get going too far, I want to know, is this a left column or right column problem? It's left column, and it is a left column problem because x comes first. Okay, that is why, because x comes first, that tells me left column. While we're here, can you identify your A and B values? A is 3, B is 2. And A is 3 because A always comes under the first fraction in a hyperbola, which is the positive fraction. Okay? So, let's see. We were asked to find well, okay, so what's it say for vertices? Yeah. Okay, so if you look up top, I was going to go ahead and do vertices first. Up in my chart, left column, it says vertices plus or minus A, comma 0. And so my A value is 3. So plus or minus 3, comma 0. Easy stuff there, right? Okay. The other thing we're asked to find are the foci. What is my formula for foci? Plus or minus C, comma 0. Virtual, I'm not sure. I don't know if you guys are right with us, but my in-class people are already telling me what I need to do here. How do we find C?
C squared equals A squared plus B squared.
Okay, C squared equals A squared plus B squared. Watch your signs. Okay? So, let's see. C squared equals 3 squared plus 2 squared. 9 plus 4. C squared is 13. If C squared is 13, what is C? Square root of 13. So what are my foci? Plus or minus square root of 13, comma 0. And again, the only time I'm going to find that square root value is if I need to graph for some reason. And I need to know how long the square root of 13 is.
So it's unlikely that we'll graph it on the test.
We won't graph this one right here. We're getting ready to graph the next one.
Oh, okay.
I mean, it just depends on what the directions ask. Okay, questions there before I move on. Again, it is a lot like example 1 from the ellipse. So it's similar to procedures you are already been practicing lately. Okay, I am ready for example 2 when you guys are. If you guys have questions out there in virtual land, make sure you ask. You're ready? Good deal. Okay, example 2. Find an equation. So we're reversing our route here. find an equation of the hyperbola with foci 0, -3 and 0, 3, whose conjugate axis has length 4. Sketch the hyperbola and its asymptotes. Okay. What information do you see?
Zero, well, it has the right column because the zero is first. That's
Okay.
all I know.
We know C.
Okay. So if you look at these foci, we can get two different things out of this information. First of all, it's 0, comma, plus or minus a number. So this is 0, comma, plus or minus 3, which fits the format of 0, comma, plus or minus C, which tells us that C is 3, and since it's 0, comma, plus or minus a number, that tells me that this is a right column problem. Okay, right column. Look up at your foci, and my choices are plus or minus C, comma 0, or 0 plus or minus C. Because 0 came first, I knew it had to go in the right column. Are we okay at that point?
Yeah, and then can't you figure out what B is too? Since
Okay.
we never come to
Well,
axis,
yeah, check your chart. What does it say about conjugate axis?
it's 2B.
Conjugate axis, according to my chart, is 2b. If conjugate axis has a length 4, then 2b is 4 and
B equals 2.
b is 2.
And then we can find A too. Minus 2.
Okay, so at this point, we know it's right column, we know B, we know C. Because it's the foci were 0, comma something, I know this is a centered at 0, 0, 1, and that's all we've learned so far. The missing piece that we don't know yet, we have B, we have C. In order to do our ABCs, we have to know A. So just like an ellipse, you guys are using your Pythagorean relationship, except that my Pythagorean relationship is C squared equals A squared plus B squared. Let's see, 3 squared, so 9 equals A squared plus B squared, which is 4. That means A squared is going to be 9 minus 4, or 5. And if A squared is 5, then A is the square root of 5. Now, for later, what is the square root of 5? 2.23 ...
You just,
Because our calculator tells me that.
Oh,
Carly must have already had it in her calculator. No, I do not expect you to know that off the top of your head.
That was what I was thinking.
What I would expect you to know off the top of your head is that the square root of 5 is 2 point something. That's reasonable for me to ask. 2.23? No, I don't expect you to know the details. She had just already done it on her calculator, so. Either that, or she has an awesome knowledge of square roots that I was unaware of. Okay, she's denying that one, so. Okay, let's see. We need to write an equation, yes? We said it was which column?
right.
We said it was the right column. So I like to write out my basic form. Right column is y squared over a squared minus x squared over b squared equals 1. That's me copying down the right column standard form. Y squared over,
It's just going to be 5 if it's square root of 5 squared.
yeah, square root of 5 squared. You know, square root of smiley face times square root of smiley face equals smiley face. Take you back to your algebra 2 days. Square root of 5 times square root of 5 is 5. Minus x squared over b squared is 4 equals 1. Okay. If you can tell, I was trying to leave my center open for a graph. Hopefully you left some place open for a graph because it did tell us to sketch. And this sketching is important. I have to instruct, like the ellipse. There was a lot to learn there, right? There's a lot to learn in the hyperbola world. So, I'm going to, attempt to put an XY axis in the middle.
This one, so when you have a circle right there, would that be our standard equation, even though it doesn't have like b squared? We have it like
B squared is 4.
like it doesn't have to be like 2 squared. We don't have to write it like that. Okay.
I think we just did that for the other one.
Yeah, because we did it for the first one. That's why.
I did it for the first one just to kind of show what A and B were. But if you're giving me an equation, most of the time we go ahead and square the numbers.
Okay.
I just did it up here in this previous one just to kind of reminder. A and B are not 9 and 4. They are the square root of those 3 and 2. So, okay, guys. So, where to begin? Okay, I have to get my thoughts together on how it's been a while. It's been since I've graphed these. We know. No, I don't graph hyperbolas in my free time. Maybe when I'm an empty nester and I don't have 2 kids running around and I'm running them everywhere around. However, I somehow still doubt it. Just saying. Okay, so our foci are 0, -3, and 0, 3, correct? So we can go ahead and graph those.
So that we know it's going to be facing up and down.
We do that. We do those.
Whatever it is.
Okay, so I put my foci at 0, -3, and 0, 3 because that's where they told me to put them. Okay, now keep in mind that 3, we went up 3 and down 3, yes? That 3 is also what? That is also my C value. So in order to get to your foci, you're always using your C value. So even if we're not told our foci, but we find our C is how we get to our foci. Now, we need our vertices. And our vertices, if you look up in a chart, are based on our A value,
Yes,
which we have an A value, correct? What is our lovely, fun A value?
Square root of 5.
Square root of 5. Thus, I wanted my 2.23 number. 2.2 is plenty. So, because we're in the right column, my vertices are 0, plus or minus A. So I'm going to go up 2.2, and I'm going to go down 2.2. Those dots represent my vertices. They are also A. Okay. The difference here is that my A value should always be smaller than my C value. In an ellipse, it was the other way around. C always need to be smaller than A. Now, we know that our hyperbolas go through my vertices, right?
Yeah.
It was discussed in class a moment ago that we know that these are going to go open up and open down. Now, the key is, how wide or narrow do I make them? And that's where we need the asymptotes. Now, I'm not going to use the equation to find asymptotes, though. A took me up and down on the main axis, right? We also have a B value. Similar to an ellipse, B takes you on the other axis. What is my B value?
2.
My B value is 2. So since my main axis is the y-axis, those are my A values. My B values are going to take me, in this case, left and right. And so we're going to go right 2 and negative 2. Now, I am not saying that you make dots there or anything. But we're going to use our A points and our B points to create a box that our asymptotes will go through. Okay, this is, I feel like, the best way to do this. So, what I'm going to do is through my A values, so through my vertices, and through my B values, I'm going to draw vertical and horizontal lines that create a box. Now,
So,
I really hope this is showing up for virtual. I'm trying to zoom. Okay, so what I did, and I just did it in pencil. Maybe I should have done it in ink pen for the benefit of,
this one, is this supposed to be through your focus though?
no. Hold that thought. We're making this box that will allow us to set up our asymptotes. We want that box to go through where the vertices are, which is your A value. Your foci, your C value, is just a point inside the box. Okay, can you guys all see the idea of the box I've done? It's just with dotted lines. It's not officially there. Okay, it's just dotted lines to help us draw it. Now, your asymptotes are diagonal lines if you look at the original picture, yes? My asymptotes go through the corners of that box. That's why it was so important to draw the box, because now my asymptotes go through the corners here. And of course, my asymptotes have to go through my center, which my center is at 0, 0. So I'm going to draw one asymptote, and you want to extend it out past your box, but it goes through the center and through the corners of the box. I'm going to draw the other asymptote. They're going to form an X. It goes through the center and the corners of the box. So that box and those asymptotes are just, officially, they're not officially lines there. If you graph this on your calculator, you're not going to see those lines there. Now, where do I draw this hyperbola? Within the asymptotes. And the main point of the hyperbola goes through the vertices, which was your A value. So your vertice is on the edge of that box. So I'm going to draw up here and up here. Notice I'm running out and alongside my diagonal asymptotes, but we're not going to cross them or touch them officially. And again, depending on this angle, your asymptotes could have set it up so we had a much narrower parabola or hyperbola. Okay, in this case, it set it up to be pretty wide. And that's what I have for you on that problem.
So for the conjugate axis, I think that's where I got confused about it having to come from foci.
The conjugate axis does not have to do with foci. Transverse axis does. My conjugate axis, so focal axis goes from foci to foci.
Yeah.
The transverse axis overlaps with that because it's vertice to vertice. The conjugate axis is the perpendicular axis that my B values are on. That is your conjugate axis.
So it's not from foci to foci? Like we have it in the...
Not the conjugate axis. The conjugate is 2B. It goes perpendicular to 2A. Yes, Jacob.
So do we figure out the asymptotes without even using we just do the box?
That's what I like to do when I'm drawing it. Okay, so the idea is, yes, we could have figured out our asymptotes here. If we would have figured out our asymptotes, it would have been plus or minus A over B. So square root of 5 over 2 times x. You would have had to have drawn a line with slope of square root of 5 over 2. Thus, the reason I prefer to draw the box. Because I don't want to have to draw a line that has that crazy slope. Is that a valid enough reason for you? So now, yeah, you can. I mean, equation. Using your a and b values, you can find that equation. In this case, it's going through the origin, so it's just all about the slope. I'm working on it.
Sorry. So it's like, can I show you what I'm asking?
Yeah.
I don't know. So, like this, like we fixed it because we talked about how it's supposed to hit the focus right here.
Yeah.
Just like that, right? So I drew that right here just like that. Isn't how it's supposed to be, though?
That's your focal axis, yeah. You don't have to draw that in, but that is the focal axis.
Oh my gosh. I got it mixed up. So then, from the foci to the other foci,
That's
the
focal axis.
I got it backwards. I'm so fine now. I understand.
Okay, are we there?
Yeah.
Okay. Okay, guys. Obviously, good stopping point. If you are interested in getting started on homework, you can do whichever ones talk about. You can get started on the ones that have a center of 0, 0. Yes? Okay. There is what the homework's going to be for lesson 8-3. Page 609, 246, so 2 through 6 evens, 7 through 10, 24 through 42 evens, 49 and 50, omit 34.
Let's still do tomorrow.
And omit means to skip 34. For those of you in virtual land that didn't hear that discussion earlier, this is not due tomorrow. It will, at the soonest, be due on Thursday. And that is assuming we get through all the rest of the notes tomorrow. So that means tomorrow we have to do examples 3, 4, and like a 5A. Maybe doable, maybe not. Okay?
So is omit a singular form of omitted? Have you guys not heard that one? Omitted?
Yeah, it's just the.
Yeah, it would be.
It would be.
Yes.
It's just a different form, but it's not.
Yeah.